Hi, teacher. My name is Changmin Zhang. So today I'm so excited to want to share you the important topic is Riemann integral with Lieberger integral. A little matrix theory in there, which well, I was so exciting because I think compare the two methods to calculate the one's content is very important, and when the time is different, they use the different weight, which have can fix full problem, and it's very interesting. So let's jump into the intro. So calculus have two major branches. One is difference calculus and second is integral, which the first one you can see the scope and curve we can calculate, which in this difference calculus is keep growing, but on the other side, a calculus of the quality, which has a lot of limit. They are from the Riemann integral generate to the Lagrange integral, and from this integral, they create to a Lagrange measure, which is measure theory. So the concept about the classic Riemann integral, because they have a column in column, every column separate very little, so you can see the interval in this period, and we calculate this value of this function, and also to calculate this length of this interval. So it's use column, right? Remember, and the new method, the Brook integral, is use the row. So the difference is the function value and corresponding the length of the domain. There are the two key points. One is the value of interval is 0, and the many of point of length of this domain also 0. The most important thing is how do we define this length, this measure, right? So in the point, it's 0 in the principle, not detail, but in the set of the interval, we can use the head to minus the tail. So it's not only column and the row. I can give a quick example because the first one, they have a dimension problem. If the dimension become more difficult or the circle, to calculate the circle, it will become more difficult and lots of work, but not precisely. And the second one is the dependency problem. And third is the limited process. The fourth is non-flexibility. You can see this formula is uneasy to change. So, and the next part, I will show the quick applied between the Riemann integral and the Lagrange integral. So you can see we mentioned about before. This is the summary of them. And this one, it is only use these two lines to calculate if the Riemann integral is the length of the interval. The Lagrange interval need to calculate all the fragmentation. So you can see as these two parts, in these two lines, they will calculate all of them into is more more detail, right? So it's high dimension and including the obstruct in the X. But the Y, they are the same in the real line. So all of part of the function, the line between the two lines will calculate all of them. We use function to send the value into the interval. So as I mentioned before, the length and the measure value is very, very important. So I think the most interesting part is even though they are the two things, but we calculate in the two weight, and they will become the total different. And they have the full problem at before, but with this different method, they will fix it. Thank you.